Hello viewers, my name is Samuel Kamau. I'm a trainer in control systems. Welcome to my channel and I hope that you're going to learn more and more. So we'll begin with the topics that we are going to undertake, and the topics are as shown. You can see them in your screen. And so we start with two topics, then the rest of them I'll be uploading more notes. So let's go through the first topic, which is Introduction to Control Systems. In the introduction, we are talking about control system whereby we desire responses, and these responses are controlled by both the input and the output, and these are what we call control systems. They can control temperatures in central heating systems, control of traffic lights, and they can also control what we call sequence of events, like in dishwashing machine, clothes washing machine, where you maybe put your clothes, then you heat the water, and then you tangle the clothes, and then you remove the clothes. Those are sequence of events. Then we also have the control of variables, e.g. temperature in central heating systems, air compressors, pressure control, even in the cistern tank where you control the water level. Control system terminologies. You have the systems where we are talking about the arrangements of components, parts from the specified inputs or input. Examples are washing machine, as I said, bread toasters, etc. Then control, where we talk about the action of commanding, directing, and regulating a system, like when you want to control the temperature in the refrigeration system and also the speed of a car. In the fig 1.1, we have the closed loop control system, whereby I have been able to give you the signals. We have the actuating signal, we have the control signal, even the feedback that comes now to feed the comparator, which compares the reference input to the feedback and then provide an actuating or an error signal. We have the plant, that is the plant. From the plant, we also have what we call the national control system. You can see there I have said that it's a control system created by God. But of course, according to the science, it is by nature, according to the science. But according to the truth, actually it is created by God. Solar system, digestive system, animal, etc. Then we have man-made control systems. We have also the disturbance. Disturbance, we say it's a signal that adverse effect on the performance of control system, which act on the controller output. For example, moving a car swept by floods, or even when we have a sunshine shining on in an air-conditioned room. Then you have controller. We also have automation, hybrid system, feedback, signal. Those are generally the terms or the terminology that we use in control systems. After the terminologies, we have what we call classification of control system. One of the classification is open loop control system, where we have a system that is open loop, and this system, it does not have a feedback, so it requires actually a human intervention for it to work. We have something like electric hard dryer, where we normally find that the hard dryer will continue to be on even when the hard is dry. It will continue to be on until you remove the hand, so it becomes an open loop system. Others include automatic washing machine, electric bulb, etc. All these require human intervention at some point. That's why we call them open loop system. They don't have a feedback. They have to be controlled maybe by a person at some point. Then we have what we call the closed loop systems. Before we go to the closed loop system, we have the advantages. Those are the advantages. We have also the disadvantages of open loop. Then we come to the closed loop system, whereby the closed loop system, even as we had seen the figure 1.1, we have it has a feedback where you can be able now to compare the controlled signal with the reference point, and so it is able to adjust. It is actually called a self-regulating. Examples of closed loop system are as shown below: air conditioning system, cooling system, overcar, and so on. You'll find that these don't require any human intervention. They are self-correcting, and so we call them closed loop systems. The advantages are written there. Of course, they are very highly accurate, and they also help in automation and many other advantages as they are listed below. The disadvantage is that they are complex design, and they are also difficult to construct, complicated for maintenance. Lastly, we have the feedback. The feedback is what we've talked about after the controlled output is measured. It is fed back. It can be fed back as a positive feedback or even negative feedback. And the following properties are imparted when we have feedback, that is increase of accuracy of the system, reduction of gain, and so on. So that is the feedback, a terminology used in control systems. The next topic we look at is what we call block diagrams. Block diagram, this one involves representation of control system in order to give an interrelation between transfer function of various components. The basic element, of course, we have the block, which is a rectangular block, and it has an input and an output. And the block, inside the block, we have the transfer function. We also have the summing point. We have the summing point, which is now in form of a circular block. We have also the takeoff point. For the summing point, we have two or more inputs and a single output. So the summing point, you sum up all the algebraic signals entering the summing point in order to get your overall the output from the summing point. For the first one, you see it is summed up algebraically, and the second one the same. Then we have the takeoff point where you are branching off from the main branch, and you have the same signal going through the branch, and then it will move towards let me see, it's a point from which the same input signal can be passed through more than one block and summing point. We come to the basic connection of blocks. You have blocks in cascade or blocks in series. When we connect them, we can be able to join them and form one single block. That is multiplying the G1 and the G2 to get one block transfer function with the first transfer function multiplied by the second transfer function, G1 and G2. It's actually the product of the transfer functions. Combining blocks in parallel. When you combine blocks in parallel, in this case, you actually add the transfer functions together to form a single block, which is shown below, where X is the input and Y is the output. Then we can also eliminate the feedback. So we eliminated the feedback in order to get just one block, and this is how one block or transfer function, one block, which is as shown below. The calculation, I have done it there, you can actually check and see. We get our, here feedback is eliminated where we have now just one block with one input, which is X, and the output is Y. Then moving a summing point ahead of a block. So when we move a summing block ahead of a block, what you need to know is that even as we move, we are not changing anything. We want the output to remain the same. That is Y to remain the same. So even as we move, we make sure that the Y will remain the same. And this is how we do it. So we just add that GS is added at a point signal along the signal X in order to get, so we get the same results. So that's how we move the summing point ahead of the block. The next moving or shifting is moving a summing point behind the block. We can also be able to move the summing point behind the block. And when we shift the summing point behind the block, then what happens is that the reciprocal of G is added on line X to give the same result. What we want to do is to just maintain the same results. We are just shifting, not changing any output. And so if you follow what I have written there, I have been able to show very well what you are supposed to obtain the same results but shift to behind. Moving a takeoff point after the block. When you move the takeoff point after the block, it means that now it will have to be multiplied by GS after it has been moved. Because of that, it changes the results. To keep the results the same, then we need to multiply by the reverse gain in order to get the same result we had there before, because the results we had was X is equals to R. So when we come here below, we multiply by 1 over G so that we can be able to get the same results. That is X equals to R. Then we can move the takeoff point before the block. So when we move the takeoff point before the block, it means that when it was after the block, it had been the signal had been multiplied by G. So if we move behind the block, we'll make sure that we add another signal, the same signal G, so that it will still remain multiplied and we get the same results. That means the same output. Moving a takeoff point ahead of summing point. Here, when we move our takeoff point ahead of summing point, what happens is that for you to get the same value, you add another summing point, the same summing point added another time in series with the takeoff with a reverse sign. This, what we are doing is just keeping the same results. We are changing or we are shifting, but we keep the same results. That is, the controlled output remains the same. Yes, then we come to the next. Moving a takeoff point behind a summing point. So when you move the takeoff point behind a summing point, we'll have a value of, the values will change, and to keep the values the same, we have to maintain the original value of Z, which is Z equals to RS and plus RY. So that's how it is supposed to be moved, just as I have shown. You can be able to see. Then steps to follow when reducing block. Here are the steps you reduce. First of all, the cascade or the blocks in series, then you come to the parallel blocks. From there, you follow the steps as are listed, and here I have an example given below. First of all, you see there is no cascade or parallel blocks, because anytime there appears a takeoff point in between two blocks, then those two blocks ceases to be series blocks or even parallel blocks, and that's why this one does not have, first of all, the parallel or cascade blocks. So first of all, we reduce the feedback H1. When you reduce this, you get the results as shown. Then, after reducing the block, then the cascade and parallel blocks now appear as shown. So you can first of all combine the blocks in cascade, and then after that you combine the blocks in parallel, and the final results you get as shown there. And then you can manipulate your transfer function there to get the transfer function as shown with the arrow. From there you can eliminate the feedback loop, and after eliminating the feedback loop, this is what you get as your transfer function. Finally, you can be able to manipulate those figures and you get your final transfer function. That is the final transfer function. Then we have the control system ratios of closed loop system. These ones, the control system ratios include the control ratio, which we can be able to calculate from the given statements, where we have a G, which is forward transfer function, H feedback transfer function, GH open loop transfer function, and so on. So control ratio, this is how you do it. You say that E, the error is supposed to be R plus or minus B. And then we have the B is equals to HC, C is equals to GE. Then using those equations, you can be able to manipulate and be able to get your C over R. That is, you making C over R as the subject of a formula, you get the ratio as shown below. Then you have the primary feedback ratio. The primary feedback ratio is actually the ratio of the system feedback to the reference input. That one also you'll be able to get from the equation 1 as shown, and you replace the E, you get your final answer as that. That is the primary feedback ratio. Lastly, you have the error ratio. The error ratio you can be able to get as shown. You can follow the steps and then you get the error ratio as shown below. Then we have multiple inputs and principle of superposition. If you have a system with multiple inputs, what you do is that you take one input and consider the rest to be zero. So you work as with that one input. You get your first control output, which is C1. The arrangement is as shown. You combine blocks in cascade, and finally you're able to get your control number one, controlled output, that is C1 as shown. Then you get the other input while considering the first output as 0. And this is what you get as shown in the equation. You are able to get the C2. When you combine C1 and C2, you get the final output. And not yet the end. Coming up next, signal flow graph. Please don't forget to subscribe and welcome.